Hello everybody, let's start today's lecture. Let me make sure if my voice is getting right. Am I? Yeah, I think so. Yeah, okay, good. So I think at the end of the operator overloading section, at the end of the operator overloading chapter, I had a few points, but I think we skipped it, or it was very fast. And I had a question yesterday from one of you. Let me find the question actually. The question was about, where is the question? Question is from Shawal. She says that, okay, here is the question. Okay. Then when I read this question, I realize that maybe I was not concise enough. Okay, to explain this, the question was about why don't we use pass by reference in our overloaded operators returns. So instead of returning a money object like this, why don't we return something like this? Okay, that's one of the, can I make this bigger? Yeah, okay, sure, I can. Yeah, okay. So first of all, this will not compile, Shawal. Okay, this will not compile because this is an address of operator. Okay, if you like to return a reference, let's go back and see our operator overload of the reference returning. Remember this index operator that we return a reference. Let's go to the implementation. The implementation just returns first or second, right? Even though I am returning a reference, it just returns first and second. So you cannot do this. So get rid of this one. Okay, get rid of this one to make it compile. Okay, let me copy this and paste it in one of the, okay, so let me get rid of this one. So this will compile, but this is not a good thing. Okay, this is not a good thing. Can anybody tell me why this is not a good thing? Do you guys hear me? Are you guys hearing me? Cheval, yeah, well, it is an anonymous object, but it is not because it is an anonymous object it is a bad thing. Anonymous objects are not bad things because, yes, exactly what Mustafa says. Okay, it is because you are returning a reference to a local object. Okay, this money will go away. Okay, this will die. This is a local anonymous object. It's a bad thing not because it is an anonymous object. It's a bad thing because it's a local object. This object will die here, but you are returning a reference to an object that is going to die. Whoever calls this operator, the unary minus binary minus operator, will be in trouble then. Okay, will be in trouble then. Okay, so you don't return a reference. You don't return a reference to an object that is going to die. How come we didn't have the same problem here with our operator overload here? Because in this case we are returning a reference to a data member of the class. Okay, data member of the class. When you say A1, okay, it returned the reference to the first, right? It returned the reference to first. When you say A1, first is not going to die after I return it because first is part of this object A, okay? Second is part of that object A. Since A is not going to die, the character pair A, okay, I am safe. Okay, so it's no problem if I do this that way. That's the first part of your question, Shawal. I hope it is clear now. And let me get to the second question. This string, I think the string class, I think, let me, okay. I think I am going to go over this today. I am going to go over the second question today. We will talk about it today. And so let me skip this question. Let me go to the third question. Third question is, you told us that a function of a class and a function of an object are two different things. I don't understand what you mean by saying function of an object. Okay, so maybe I misspoke a little bit. When I say function of an object, there are no things as functions of objects. There are functions of classes. I think when I said that, that's what I meant. There are no functions of objects. There are functions of classes. Okay? I think it was because somebody was asking me a question like this. Maybe let me try to find that example. Okay, this is a good question. Chapter 8, right? Chapter 8, maybe this one. Integer pair. No, not that one. Maybe this one. Yeah, okay. No, not that one. I don't wanna, I like to find I don't want the friends. Maybe this one. Yeah, okay. So the question was this. I have a binary minus operator. Okay. This binary minus operator takes another money object. The question was this. How come I can access the private data members of another object? Okay. So as you see, I have access to the sends part of the second operand, and second operand is not my object. And what I said was the rule is the private parts or the public parts are private or public parts of a class, not objects. Okay, so there are no private parts of an object. There are no private parts of a object or public parts of an object. There are private or public parts of classes. Okay, similarly, there are no public or private functions of objects. Okay, there are private or public functions of classes. Okay, that's why if I am in the same class, I am in the money class. Okay, I am in the money class, I can access all the private and public data and function members of all the objects. That's what I meant, I think. Okay, so that's the answer to your third question. Okay, so let me go back to my slides, and in the book it said that, okay, I think we talked about it. I could return. Okay, I think that was let me get these out. I don't want to. Okay, get rid of this one too. Okay, good. This one. So okay, the question is this: character pair B, and I think it can take two parameters like that. Let's say this is Q and this is W. Okay, this is good, no problem. How about if I do this? Can I do this? Line 22? Of course, why not? I can do this, no problem. Okay, no problem. And since this is a constant object, when I do this, B and index operator, if I can find it. Okay, I think it is here, like that. Okay, B1, or maybe before that, maybe I should do this. Didn't I just find it? Okay, B1 gets the value of E. Okay, what is the problem with line 24? Line 27 is fine, right? Line 27, no problem. But line 24 is bad. Why? Because B is a constant, right? Since B is a constant, I should not be able to modify. The content of a object, constant object. Okay, so this is a compiler error as expected. Okay, compiler error. This is not a good thing. How about line 25? Is line 25 okay? Yeah, it should be okay, right? It should be okay. Why? Because I am not modifying anything, right? I am not modifying anything. I am just printing the content out. But again, this is a compiler error. Why? Why is this a compiler error? Line 25 is a compiler error. Can anybody tell me why? Yes, exactly what Jakub says, what Ahmed says. Because the index operator here is not a const function, okay? It says that I work on non-const objects, okay? I work on non-const object. This is a const object. B is a const object. So what are we going to do? I think I did this before. So what are we going to do is, maybe in that case, I will do this. I will just make this const. Okay. Since it's a const, it should return a const reference. Otherwise, I would modify it. So this should fix it, right? So This is a compiler error as we expected, line 26, because b is a const. Now this will work, right? This will work because I am returning just taking it's a const operator and it returns a const reference. I'm not modifying anything. As expected, this is not a compiler error anymore, okay? This is not a compiler anymore. This is okay now. But the problem is this, A1. Now A1 is going to give me an error message. Why? Because index operator is a const, okay? Index operator is a const operator. It returns a constant character reference. I cannot assign a letter, a character, to a constant character, okay? So line 29 will not work now. So what are we going to do? This is what we're going to do. We are going to define two index operators. One is going to work on the const objects. The other one is going to work on the non-const objects, okay? So line 13, okay, this compiler error, this is line 13, okay, but this one is line 13, and this one is, no, this one is not line 13, this one is line 14, and this one is line 14, okay? How about this one? Which one is this, line 13 or 14? 33, line 13 or 14? Exactly, line 14. Why? Because A is a non-const object. For non-const objects, this is going to work. Okay. You might say that I don't understand. I mean, I am not modifying anything in there. Why does it make any difference that this function is a const or not const? It is modifying. It is not modifying anything. But the important thing is this: even though you are not modifying anything within this function, it matters what you say at the function header. Okay, you are saying that this is a const function. This is a non-const function. The compiler doesn't care if you modified anything in the function or not. As long as you say non-const function, it says that it's a non-const function. Okay. So the book has a explanation about this. Say that, okay, if you are returning a reference, there are two ways to return it. Okay. One is a reference directly, non-const reference. The other one is a const reference. Usually we have to do both. Okay, for these kind of cases. One is going to work on the const object, the other one is going to work on the non-const objects. Okay, the one is going to will be used as an L value, the other one is going to be can be used as an R value for const objects. Of course, these two are overloads. Remember what the overload, the meaning of the overload? The meaning of the overload is this. Two functions can have the same name as long as their parameter types, number of parameters, and their qualifiers are different. These two, they look like their signatures are the same. Why? Because they don't take any parameters, right? They don't take any parameters. Okay, their number of parameters is 0. Their names are the same, but one of them is a const function. Okay, one of them is a const function, the other one is not. So their signatures are different. They can coexist in the same class. Okay, so that was it. And at the end of the chapter, the book gives us this slide, actually, this piece of table. Okay, if you are returning something from a function, you could return an object. Okay, this is returns by value. Okay, value is copied. A copy of new object is going to be made here. T, a new copy. Again, a new copy of an object, but this is a constant object. You cannot modify it. A reference, non-const reference, and a const reference. We have to be very careful with these two because we should not we should not return references to local objects or objects that are going to die. Okay? If you return a reference to an object that is going to die, you will be in trouble. Whoever calls this function f will be using a non-existent object. It's going to be a dangling reference. It's going to be a memory problem. So whatever you are returning, make sure that whatever you are returning as a reference, make sure that that thing is not going to die. Okay, that thing is going to live for the caller of this function f. Okay, I think that was end of that chapter. Yeah. Okay, good. Any questions about this? I think I talked about this, but that was maybe I was very fast at the end of the chapter. My plan was to go back and make a repeat, but I forgot. So a good thing Cheval asked that question. If you don't ask me questions, I would not know what you think. I would not know what you did not understand. Okay? Don't do this. Don't make a plan on, I will catch up later. Okay? If you make a plan on you would catch up later, you will fail. Okay? Because when you try to catch up, you will see that there are many things that you did not understand, and you will not find anybody to ask your questions. Okay? So try to be on time all the time. Okay, come to classes, read the book before you come, and ask your questions before during the classes or after the classes, so that you are not falling behind. Okay, good. So let me go back to chapter 10, and remember this is this operator. We talked about this operator, and this will come again and again and again. Okay, we will talk about this operator. Sorry, this pointer. This is not an operator; it's a pointer. Okay, we will talk about this, and you will see that it's a very useful thing. Okay, let's talk about the assignment operator. Actually, we talked about the assignment operator before in chapter number 8. Okay, and since we know about the references now, okay, we are gonna see examples of assignment operator overloaded properly. Okay, so when we do this cascaded, okay, chains of assignment operator or cascaded assignment operators, okay, what is the associativity of the assignment operator from right to left? So associativity of the plus operator is a, when you say A plus B plus C, okay, this plus is going to be done first. So if I draw the tree, okay, evaluation tree, expression tree, this is the tree, right? Okay, A plus B will be done first. The result will be added to C, but for the assignment operator is going to be like this. First, it had to be B and C. Okay, I will make an assignment between B and C, assign C to B, then the result will be assigned to A. Okay, because the associativity of the assignment operator is different from the others. They make this decision when they design the language of C. And we cannot change it, as you know, with the operator overloading. You cannot change the precedence of the operators and the associativity of the operators. Okay, and since I am going to return whatever I have assigned, it would make sense to return a reference to myself, okay, in an operator assignment, so that this can go on. So this pointer will be helpful when we do that. Okay, so let's see an example of this one. I think instead of doing this, I will show you an example. I think this was in the video and you are supposed to watch the video, but I will talk about it again. Maybe I will not. Maybe instead I will try to go over an example. No. I think I will continue here. Okay. Let's say we have a string class like the class that Shaval copied a few minutes ago. I have the assignment operator. Okay. I don't know what this length is doing here. Okay, get rid of it one. Okay. I have an assignment operator. As you see, the assignment operator takes, remember, assignment operator has to be overloaded as a member function. Assignment operators cannot be overloaded as a friend function or global function. They have to be member functions. Okay. So as a member function, I am overloading the assignment operator. On my right side, I am taking a string class object. This is a string class. Okay. And I am returning a reference. I am returning a reference to a string. What do I return? Okay, this is going to be very useful here. What I return is a reference to myself, as you see. I have two parts of this f, the first part and the second part. The first part returns a reference to myself. Okay, and the second part again returns a reference to myself. Good. So, what did I say? This pointer will be very useful for doing this. Why am I returning a reference to myself? Because I like to be able to do this kind of stuff. Okay? I like to be able to do this kind of stuff. The book gives this example, but it is a little bit not right. Why? Because I like to be able to do this. Why am I returning an unconst object as a reference to myself? Okay, I mean, I don't want anybody to do this, something like this. Okay, let's say C and D are money objects, and when I do this, okay, I don't want anybody to set dollars. One. I don't want anybody to do that kind of stuff. Remember why we have returned it. So since I don't like this, let's return a const. Okay. So this is better. How about this? Should I put a const in here too? Let me do this. I like the blue const. How about this green const? Should the green const be there? Yes. No, because if you have a const here, you cannot modify the data members of the class, right? So the green const should not be there, right? This is a bad thing. So I am not a const object, but I am returning myself as a const object. That's okay. Okay. So this is good. This is good. So let's look at this implementation. It looks like, and we are going to come back to this example again. It looks like my string, let me try to draw my class diagram, string class. It looks like inside my string, in my private part, I have a capacity integer, I have length integer, and I have a data member named A. It is a character pointer. So this is my string class's private parts. Okay. So when I make an assignment from one string to another string, I don't like the default assignment operator, because the default assignment operator makes a memberized copy. Okay, so let's try to explain this in a more careful way, detailed way. Let's say, what is the name of the class? The name of the class is string class. Okay, string class, two objects, s1 a b c and s2 d e. Okay, so we don't know the details, but it looks like s1 is going to be like this: object s1, and there is this object s2. How many things there are in object s1? 3 things. One is the capacity, the other one is length, the other one is character pointer A. The same thing for s2: capacity, length, and the character pointer A. For s1, I don't know how they set the capacity. Let's say the capacity is 10. Okay, the length is just 3, because there are 3 letters in it. How about A? A is a character pointer, and it's a pointer. It should point to somewhere, right? So it's going to point somewhere in the memory, and something like this. It is A. Let me do it properly. Characters A, B, and C. Okay, so this is somewhere in the memory. And similarly for S2, let's say the capacity is 10 again. The length is 2. This time this A is going to point somewhere in the memory like that, maybe. Okay, A is pointing to here, and there are 2 letters, D and E here. Okay. If I do this, let's say I try to do this. If I do S1 gets the value of S2 assignment, what would happen if I don't overload the assignment operator? If I don't overload the assignment operator, what is the default meaning of the assignment operator? Memberized copy. Again, remember, memberized copy. Okay, when you do the memberized copy, I will copy each element one by one from S2 to S1. So let's see what happens. Let's copy capacity to capacity. So I will copy, okay, let me try to write them in green. I will do this. I will take this out and write 10. Nice. I will take this out and write 2. Nice. And I will take this out. Okay, I will take this out and copy whatever it is content is, and I will make this copy. When I do that though, I will do just this, right? So this green arrow will be gone. No, sorry, I did the wrong arrow. So this green arrow will be gone. Okay, so do you see the problem here? if I do the memberized copy, what happened? Tell me what happened. Mustafa, explain that a little bit. What do you mean by memory leak?
Sir, ABC memory area pointed by S1's A disappeared.
Yeah.
We cannot reach it.
Yeah. So nobody is reaching ABC, right? ABC, we lost handle to ABC. Nobody is reaching it. That's one thing. That's a bad thing. But there are even worse things here, right? What is worse? Worst thing is this. Worst thing is this. Both S1 and S2 are sharing the same string here. Okay. If I modify S1, let me do it. S1, let's say 1 to Q. Okay, so this one is going to change. It will change from E to Q, right? So it will change both of them. Okay, it will change both of them. I don't want to do that. I mean, the fact that I did an assignment doesn't mean that I want this. Okay, this is kind of a mix between an assignment and a reference thing, right? I don't want to do that. Okay, that's another bad thing. But the worst thing is this. Let's say S2 is killed. When S2 is killed, okay, this one will be gone. While this is going, it will take this away too. So that will leave S1 in a very, very bad situation. Why? Because now S1 has a what? Now S1 has what? S1 has a dangling pointer, right? Yes. So if you do this, it's a very rare thing actually. You are achieving both memory leak, dangling pointer, and a logical error, all of them together. So in your classes, if you have structures like this, okay? If you have two integers, no problem. Memberized copy works very well with the integers. But if you have pointers, and if your pointers are pointing to outside objects like this, okay? I have two pointers and they are pointing to outside objects, then memberized copy doesn't work very well, okay? Memberized copy is bad. What should I do? When you are doing the assignment operator, okay, you should copy everything yourself. For this data member A, the character pointer, you should make sure that you have space, your own space, and you do your copy yourself. Okay, that's why if you have structures like this in your class, you should do your own memberized copy. Okay, you should do your own assignment operator, and memberized copy is not going to work. That's what this function does. Okay. This one says that, okay, at the beginning, if my right side, if somebody says A assignment B, if somebody says that, okay, if somebody says this, first I am going to make sure that my right side, okay, if it is the same as me, if the address of right side is not address of myself, then I will do this. But if it's the same, then I don't have to do anything, right? So it means that if somebody does this, A is assigned the value of A, then I will hit here and I will return a reference to myself. I am not going to do anything. I don't have to do anything. Okay. So why should we be careful about this? Why should we be careful about this? We will see in a few minutes. So this is not for efficiency. I mean, this is good for efficiency, but it is not just for efficiency. It is for some other reason. Okay. So let's look at the other part. If this is not the case, if A and B are two different things, their addresses are different. So what I do is, okay, for the capacity and length, I will just copy them, right? From right side length to capacity, from right side length to length. Okay, I do that. Okay, let's try to do the same thing here. Let me raise this green stuff if I can. Erase this. Okay, 10 goes this one. The surgical procedure. Yeah, I think I did it. So it used to be like this, right? Let me get the blue pen. It used to be like that. Okay, so let's try to make this a little bit smaller and put it there, and let me make this a little bit larger and put it up here. Okay, so that I can explain it a little bit better now. Okay, so this is what we do. Let's say I am again doing this. S1 gets the value of S2. Okay, S1 gets the value of S2. So when I do this, right side length, that is right side is S2. Okay, S2 length is going to be copied. S2 length is going to be copied here. Okay, and then, oh, okay, no, it says that capacity of okay, capacity of S2 is going to be a capacity of as you see, I am copying. Let me do this. Let me change this. This is correct, but for the sake of a little bit more clarity, let me make this capacity. This is correct, but this is easy to explain. Okay, so I will copy the right side capacity, which is 10, to this position. Okay, and it is 10. And I will copy the length of right side to this position too. And then I will delete A. What does that mean? A is this. Okay, A is this. I will delete A means is that I am telling the system that I don't need this memory location anymore. I don't need this heap space anymore, right? I don't need it. So what am I gonna do? I gave it away. So my A, character pointer A, is not pointing to anywhere meaningful. Okay, is not pointing to anywhere meaningful. So what am I gonna do now? This is what am I gonna do. This is what I am going to do. I will make a new character array of size capacity, and it will be here of size 10. Okay, capacity is 10. As you see, the capacity is 10. And then I have a loop I have a loop that will run from 0 to length, which is 2, and I will copy from this location, right side AL to AL. So I will copy first that D, then I will copy E. Okay, and then I will return, and of course after the assignment, now I have this. Okay, so then I will return a reference to myself. As you see, I don't have the dangling reference problem here. I don't have the memory leak. I don't have the problem of two objects sharing the same character array, right? So no problem. Okay, so this is how you overload your assignment operator if the member-wise copy doesn't work. In this case, member-wise copy is not good for us. We have to write our own. Assignment operator. This is called deep copy. Deep copy, as opposed to member-wise copy or shallow copy. Shallow copy is member copy. Shallow copy is sığ kopyalama, derin kopyalama. We did the deep copy here. Why? Because we copied the data members, but for the pointers we went deep. We went deep into the we followed the pointers and we went deep into the object and we copied whatever they are pointing to. Okay, if you just copy the pointer itself, that becomes a shallow copy. I think that was this example, that was this explanation in the book. Shallow copy is assignment copy is only the member variable, contents over. Okay, default assignment works that way. But with the deep copy, okay, it involves pointers and dynamic memory. Okay, must dereference pointer variables to get to the data for copying. Okay, so I need to follow the character pointer A. Okay, I find its contents and I copy them myself. For that one, of course, I need to delete my old place and I need to get new space. Okay, that's called deep copy. Okay, usually the reason why we need the assignment operator is we need a deep copy instead of shallow copy. Okay, we need a deep copy instead of shallow copy. Okay, good. Any questions about the assignment operator? I am going to show you one full example about a string class. Also, the book has a partial filled array class, and we will see examples of this. Mehmet has a question. Hocam, what did we return at the end of the function? We returned a reference to myself. When we do this, okay, A gets the value of B, A gets B. What did we return? We return a constant reference to A. Okay, both sides of this if. Okay, but they are at the end. Okay, at the end they are returning a reference to the object itself, but it's a constant reference. We did that so that I can do this kind of stuff. This one will return a reference to A. This one will return a reference to C, and this one will return a reference to E. Okay, good. Any other questions? Okay, if there are no questions, let me take 10 minutes of break. After the break, we will come back and we will continue talking about these. Okay, so let us be here around 11:32. Hocam senin sıkı dinlenmen lazım ya. O kendi kendine toparlıyor işte. Okay, people. The Gebze Technical University Computer Community and Turkcell Technology, I think they are planning a joint activity together on December 21st. This is the announcement picture. If you are interested, just join it and it should be helpful for you. Okay. So we talked about the assignment operator, and we are going to see a few more examples of assignment operator. If you did not understand it fully, that's okay. We will do a few more examples, but it is important that it is important to understand why we need to overload the assignment operator for some cases. If you don't overload it, there will be a default assignment operator, and it will not be good, especially for classes like this. And that's why it is very dangerous to leave it as it is. For these kind of classes, you need to overload it, because this class needs definitely a deep copy, not shallow copy. Okay, so one important concept in object-oriented programming languages like C++ and Java and C# is destructors. Okay, destructors are like opposite of constructors. Remember, the constructors are called when you make a new object, right? When you make a new object, constructors are called. Let's say I have a function f that doesn't take any parameters, doesn't return anything. I have a money object m1 and another money object that takes $10.20. Okay, I know that two objects are created here, m1 and m2. No parameter constructor will be called for m1, and the constructor that takes two parameters will be called for m2. I know this one because that's the rule of the language. There are, as I said a few minutes ago, there are destructors defined in a class, okay, which are called when these objects go away, when they die, okay. At the end of this function here, M1 and M2 will die. When they die, just before they die, their destructors will be called. Okay, so destructor is a special function like constructor, is a special function, and there is only a single destructor. You cannot overload the destructors. Destructors don't take any parameters. They don't take any parameters. No parameter they take, and they will be called automatically by the compiler just before the objects die, they go away. So here at the end of this function, the destructor for M1 and destructor for M2 will be called. For now, we did not define any destructors because we didn't have to, because when the object dies, it just dies. We don't have to do anything. But if we didn't have to do anything. But if we have dynamically allocated variables in our classes, then who is going to delete them? Okay, what is the rule? For every new operator, there should be a delete, right? And for every delete, there should be a new. So if I have a new operator in my class, okay, if I created dynamic memory using the new operator, who is going to delete them? Okay, when the object dies, the deletion will not be done automatically. I have to do it myself. So Destructor is a very good place to do this deletion. Okay, do this deletion. So dynamically allocated variables, they don't go away until deleted. And if you don't delete them, and if your objects die, then you will have memory leak because you are not deleting them. Okay, you are not deleting them. So Destructors is a very good place to make this deletion. And the name of a destructor is like very similar to constructor. If your class name is my class, your destructor name will be tilde. Okay, tilde my class. Okay, this is called a destructor. As I have mentioned before, it doesn't take any parameters, and like the constructor, it doesn't return anything, not even void. Okay, and like the constructor, the destructors are called automatically. You don't call them. You never call them in any way. Okay, you don't call them in any way. They are called automatically by the compiler when your objects die. Okay, this is one example of a destructor. As I said before, destructors are not overloaded. Can you tell me why? Constructors are overloaded, and we have seen many examples of it, but destructors are not overloaded. You cannot overload a destructor. Can you tell me why? Okay, exactly what Merve says, because destructor doesn't take any parameter, right? If destructor doesn't take any parameters, how are you going to overload it? Constructors take parameters. How do you overload the constructor? By writing different constructor that takes different types of parameters, either doubles, integers, or different number of parameters, right? Destructors doesn't take any parameters. That's why you cannot overload them. Okay, and when you make a new object, okay, a money object or a rational object, doesn't matter. You usually pass the parameters when you make the object creation, but the destructors, you don't call them at all. You never mention them. They will be called automatically by the compiler. Okay. Enes, what you are saying is wrong. Destructor is only called delete operator. No. Destructors are not called by the delete operator. Okay. I don't see any delete operators here. Okay. There will be two constructors called for this. and there will be two destructors called at the end of this function. You don't need the delete operator to call the destructor. Okay, let's do this. Okay, so two constructors will be called. How about this one then? Money pointer MP gets new new money, just $12. This is my whole code. Okay, just 2 lines of code in this function. Tell me how many constructors are called and how many destructors are called. First, the constructor. How many constructors are there? How many constructors are called for this function f? A function f that takes just 2 lines of code. Three constructors. Why? Because there is one constructor here, there is another constructor there, and there is another constructor for this new operator, right? So 3 constructor, 3 money constructors there. How about the destructors? How many destructors are called for the money class, money objects? How many destructors? 0 is not the correct answer. 2 is the correct answer. Why? Because M1 and M2 are how many? Okay. So 2 is the correct answer. 2 is the correct answer. Another question. How many automatic variables do I have in this function? How many automatic variables do I have in this function? People are saying 2, one somebody says 4. Yeah, Gökbey is saying 3. 3 is the right answer. Gökbey, tell me what are they? What are your 3 automatic variables? Yes, exactly. M1, M2, and MP. M1 and M2 are money objects. MP is a money pointer. They are all automatic. How many dynamic variables do I have in this function? Just one. It is this one. So there are total of 4 variables, 2 automatic money variables, 1 dynamic money variable, and 1 automatic money pointer variable. So how many destructors are called in this function? 2, just for this one and this one. When this function ends, okay, the destructor for M1 and destructor for M2 will be called. Okay, for this simple type integer money pointer, there are no destructors. Okay, this is a pointer, it's not a money object, it's a pointer. Okay, and no destructor for money will be called. So that's a bad thing, right? So what do we call this problem? What do we call this problem? There is a, what kind of problem does this function have? What kind of problem does this function have? Memory leak, exactly. It is memory leak. Why? Because I created this money object on my heap and I did not delete it. Okay, since MP will die, nobody is pointing to that money object anymore. So there is a memory leak. How do I fix this problem? Whatever I do here, at the end, I should delete this MP. Okay, now I have 3 destructors for money and I have 3 constructors for money. Okay, so I come here from Enes's comment. He said that destructor is called by the delete operator. No, it doesn't have to be. This delete operator deletes this money object, but before the money object is deleted, the destructor is called automatically by the compiler's code. Okay, so this is a new concept that just we have introduced. Okay, it's called destructor, and destructors are written that way, and we use destructors to clean up the memory that is created by that object. Or sometimes we close files. For example, if the constructor opened a file for that object, it's a very good place to close that file. Or remember, we used to count the objects created, right? Do you remember using the static variables? If you are counting the object created, when the objects die, if you decrement that count, then we can count the objects deleted, and the difference would give you the objects alive. Okay, the difference would give you the objects alive. That is, you know the number of objects created, you know the number of objects dead. So the difference would give you number of objects alive, right? So that's a very good place to do that kind of stuff. Open files. We use constructors to use the new operator. Okay, constructors to get memory allocation, destructors for deleting the memory that we have allocated. We use constructors to open files. We use destructors to close files. Okay, we use constructors to increment the number of objects. We use destructors to decrement the number of objects, etc. So constructors and destructors are kind of parallel. Okay, and we use them a lot. And if you have dynamically allocated space in your classes, then destructors are very good places to delete those dynamically allocated spaces. Okay, so destructors are very useful. One thing to note here. Remember my favorite class? Class A. Okay, when you say class A, what is available for this class A? There is a default constructor, right? It is available. There is this default assignment operator. It is available too. Okay, but you don't have the destructor available for class A. If you did not write any destructors, okay, you don't have a destructor. Okay, so the destructor for class A will not be called. There is no default destructor. Okay, good. What kind of other? Okay, here's a question for you. Class A is this, and I have an object of class A. Size of A. What do you get on the screen? What is 1? Why it is 1? Where did you get 1? Okay, people are not saying 0. Okay, so, well, maybe this question is too early for you, but I mean, the class, empty class like this one is not empty actually. There are some stuff in it, and you tried it. Okay, Mustafa says he tried it. Yeah, that's good. Okay, so it doesn't have to be 1 all the time. It depends on the operating system. It depends on the compiler, and the compiler switches too. Okay, usually in every object there is hidden information that gives you information about the type of the object. Sometimes during the runtime you need to determine the type of the object, and those kind of stuff will take space. But it is possible to turn it off, and sometimes it is possible to make the size of this kind of object 0. Okay, so this class is not an empty class. There are many things happening with it. Okay, we know that there are default constructor, that we know default assignment, and we are gonna see there is some other default stuff, and we are gonna see it in a few minutes, and it is called Copy Constructor. Okay, Copy Constructor is a special constructor. Copy Constructor is a special constructor, and As the name implies, it is a constructor, like a regular constructor. But for the money class, copy constructor is this. For the money class, copy constructor is const money. Okay. It takes another money object as a reference, and it says that, okay, I will make a copy of this object, and I will make a new object. This is called copy constructor, and you might say that, well, I mean, yeah, this looks nice, but why is it so special? I mean, it just makes a copy of this thing. Let's write this copy constructor. Can we write it? Just let's write it. How do I write it? Yeah, I don't remember the money class actually. How was the money class? Let's find the money class. Is this? Let me open the money class interface. I guess it was here. Are there no set dollars thing? Okay, dollars and sets. I think I am going to just do this. Okay, I am just going to do dollars, and let me give a name to it. Other money dollars, other money dot dollars, comma, cents, other money dot cents. And I don't think that I am going to do anything else. That's it. I just copied the contents of other object to my object, and that's it. I am not going to do anything else. Okay, so this is a copy constructor. I copied the contents of other object to myself. I get it as a const reference. I said that I am not going to modify it. Yes, I did not. And I said that it's a reference to be more efficient. So what makes this copy constructor special is this. Copy constructors are automatically called. Okay, copy constructors are automatically called when you pass an object to a function using call by value. Okay, call by value. Let's say I have a function, global function, void f. It takes a money object. I don't know what it does. Let's say cout m. Very stupid function. Okay. In my main function, if I have a money object m1, and if I call this f on this m1 by call by value, see, this is call by value, not call by reference. So somebody has to make a copy of this m1, right? M is a copy of m1. Who is going to make that copy? This copy constructor. So what if there are no copy constructors? If there are no copy constructors, then the compiler will make one copy constructor for you. So there is a default copy constructor. Okay, like the default constructor, there is a default copy constructor. That's why if you did not write anything in this class, we said that there is a default constructor that takes no parameters. There is a default assignment operator that does the memberized copy, and there is a default copy constructor. Okay, there is a default copy constructor, and this default copy constructor is used to make copies of your objects. Okay, in this case, who is going to make the copy of this M1? Here, this copy constructor will be automatically called. Okay, do this experiment just right after the class. Do this experiment right after the class. Write this exact code using your money class or some other stupid class, doesn't matter. Okay, do this experiment, and inside your copy constructor, write some printouts. See out copy constructor here. Okay, something like this. See out copy constructor. Okay, okay. When you make this call, you will see that as soon as you make this call, this copy constructor will be called automatically. Okay, you cannot say I'm not calling this, it will be called automatically. If you don't define your copy constructor, and a default copy constructor will be called. And how does that default copy constructor work? It is very similar to assignment. It does the memberized copy. Okay, so like this here, default assignment, both of them, these two, they do memberized copy. Okay, default assignment and default copy constructor, they do, let me write this explicitly, assignment. Both of them do the memberized copy. Remember, memberized copy is good for most of the time, but it is not good if there are pointers in my class. So that means that my copy constructor, the default copy constructor, will not be good for if I have any pointers most of the time, if I have pointers in my class, or if my class needs deep copying. That's the correct way of putting it, actually. Because for some very rare cases, even though I have pointers in my classes, I may not need deep copy. But if you need deep copy for your classes, then definitely the default copy constructor and default assignment operator is not going to be good for you. You need to write your own assignment operators and copy constructors. Okay, so copy constructors are like that, but call by value function, call by value is not the only place where copy constructor is called. Okay, this is just only one position. Okay, this is the third one. Okay, this is the third one. When you make a call by value function call with your objects, it will be called. That's where the copy constructor is needed. That's one place. The other place is this. If I do this, okay, this will be clear, but I have to do this. When you say money M1, M2, okay. How about this? Money M3, okay, M1. Of course, in this case, copy constructor is called. Okay. Of course, in this case, the copy constructor is called. Also copy constructor called. Also, this may not be very clear from the notation, but in this case, copy constructor is called too. Money M4 initialized with M1. Again, copy constructor is called. Okay, this looks like an assignment. This is not an assignment. Okay, this looks like an assignment, but it's not an assignment. This is a copy constructor, actually. This is copy constructor and this is copy constructor. So what I am here saying is this part corresponds to this 3. This is 3, right? Okay, and this part corresponds to 1. Okay, 1. And for 2, I am going to write this. Let's say I have a function f that doesn't take anything but returns a money object. Not reference, but a money object. I did things, I don't know what I did. I did many things, and at the end I said return money $10.20. In this case, I have to make a copy of a money object because I am returning by copying, right? And in this case, let me use the black pen here, and this is the second one here. When function returns class type object. Okay, so copy constructor is used in many places transparently. You don't realize that it is being used. Up to now, we were okay to use the default copy constructor because the default meaning of member-wise copy with the copy constructor was fine. But now with this string class or the pointers, it is not fine anymore, because if you don't define your own copy constructor for the string class, it will be shallow copy, and shallow copy is going to create memory leak and the dangling references and the logical errors. That's going to be very, very bad. That's going to be very, very bad. So these are some, it might look like detailed topics and this is too much detail. How am I gonna remember it? It's not that difficult actually. All you need to remember is this, okay? If you have a class like that, you have to be careful. This class has default constructor, it has default assignment operator, and it has default copy constructor. Okay, these are definitely defined. And for some reason, for your classes, if these defaults doesn't work, then you need to overload them. It is not an option. Okay, you need to implement them. Sorry, not overload them, but implement them. This is not an option. Okay, this is not an option. Why? Because if you don't define your assignment operator or copy constructor when it is needed, your customers will be in trouble when they use the assignment operator or the copy constructor. Okay, it is even more dangerous for the copy constructor because your customers might use call by value with your objects, and without realizing that, they will be in trouble because with the call by value they will be using copy constructor automatically, and that way in that way they will be in trouble. Okay, so Gökbey has a question. Copy constructor has a money object parameter. What is the parameter in this situation? fm1. What? This is the function f. The parameter is this. This is the function definition of f, and it takes the money object by call by value. When you call f m1, the parameter for f is m1. Since this is call by value, m has to be a copy of m1. This is not a call by reference, okay? Call by value. M has to be a copy of m1. Who is going to make this copy? This function. Is this clear, Gökbey? Did I understand your question right? I don't understand what you are saying. This is a constructor that takes a money reference, constant money reference. And this constructor is automatically called for this parameter, money m. So when you make a new object, a constructor is automatically called, right? What kind of constructor is going to be called for this money m? This constructor. So what is the parameter for this constructor? This m1. And if you have this kind of question, why don't you use your microphone? Why am I waiting for you to type something? And not only me, there are 90 people waiting for you to write something, right? Okay, so let's go back. I don't know what you mean. Maybe just send me an email after the class. Okay, I don't know what you understood, but I did not understand your question. So let's go to the examples from the book, and okay, we already did that. The book has a question, has a example about, yeah, partially filled array. Yep. The book says that I am going to write a new class. It's called partially filled array. And in fact, without looking at the class itself, let's look at the main or the driver code. Okay, so this is test partial filled array D, double array. It says that enter me a capacity of the super array, and partial filled array is my class name, and temp is my object name. This is the capacity. So the idea is this. With the partial filled arrays, if I have a partial filled array, P partial filled array, let's say my array, if it is 30, that means that in my memory, somewhere in my memory, there is this array, okay? It's going to have somewhere a double position for a 30 doubles, okay? There are 30 doubles, and it's going to point to that location. Also, inside this array, there will be, okay, there will be capacity and length and a double pointer. Okay, this double pointer will point to this array here. The capacity will be at the beginning, it is 30. There are 30 doubles that could be there, 30 doubles in it. The length will be 0 because I did not put anything in it yet. Okay, that's the idea. So let's go to the code again. It says that how many doubles can be in the array. Okay, there could be at most, let's say 30. Now enter up to 30 non-negative numbers. At the end, place a negative number. So I am using negative numbers as a sentinel value. Okay, so I get a double from the keyboard. If that double is greater than or equal to 0, and if temp is not full, what is temp? Is our object. So full must be must be one of our function members. It's going to return false if I don't have, if it's going to return false if I have space to put these numbers in. So if I have less than 30 elements inside this array, partial filled array, it will return false. If I have 30 elements, then it will return true. if the array is not full, I will call this function, member function, add element. Okay, add element. It's like pushback of the vector. Okay, double vector, right? Then I will get another one and I will put them back inside my partial filled array. And then after the loop ends, either it is full or I enter the negative number. Okay, after that, I get this, I call this function get number used. Okay, and then what I do is I will say that there are this many elements in my array, and then in a loop I will print out all the elements inside this function. So it looks like I overloaded the index operator, right? So how many functions do I have with this class right now? I have, of course, the constructor that takes a single parameter, the function full, add element, get number used, and the index operator. That's what I have seen. Okay, so these are my functions that I have seen from this one. So this is a array class, a double array class. Okay, that can hold up to capacity number of elements in it, and it keeps that data using the dynamic memory. So it's going to use a new operator inside this constructor. Since it is using the new operator inside the constructor, it has to delete that space inside the destructor. And since I have pointers inside this class, I need to overload the assignment operator and the copy constructor. I need to overload the copy constructor and the assignment operator. And also I need to provide the destructor because destructor is needed in this case. Okay, let's look at the interface of the class. The class interface that doesn't include any private information or the details of the implementation. PFD, no parameter constructor here. Okay, so we are done with the default constructors. A constructor that takes a integer, so it is the capacity. And here is our copy constructor. Okay, so I have three constructors. One, I have three constructors. One constructor that takes the capacity, another constructor that takes another PFD object, constant reference object. Add element takes a double and it adds this element to my array. Full, okay, the full function is a boolean, returns a boolean, it's a const, of course, it is not modifying anything. Since it is simple enough, I inlined it. Okay, I say that if let's look at this private part too. I have used, I have capacity, and I have the double pointer A. Okay. So if capacity is the same as used, then I am full. I cannot add more. I cannot add more. Okay. Get capacity is a constant, get number is a constant, and they return the capacity unused. Empty array is not a constant. It says that my use is going to be just 0. So even though I have enough space as many as capacity, my use is going to be 0. And this one is the index operator. Okay, this index operator is going to be used for indexing. And as before, I am going to do this right now. Okay, and here constant, and this one is constant. So I have both of them now. And assignment operator has to be there, and destructor is there. So actually these three go together. We like to put them together, and these are called big three. Okay, big three functions. Why do we call them big three? Because they are very important. Okay, they are very important. If they are needed, you need to overload them, you need to implement them. Okay, provided. I provide these big three and with a comment. If these big three are not needed, like in this function, in this class money, I would put a comment here saying that big three is not needed. Okay, I put this comment here. Okay, saying that I did not implement the destructor, copy constructor, or the assignment operator because defaults are okay. Okay, or sometimes default big three is okay. I put this comment in there so that the reader of my class doesn't make a mistake thinking that I forgot about it. Okay, I forgot about it. I did not forget anything. I did not forget anything important, and I am making this explicit by putting this comment in here. Okay, so if I go there, I say that okay, I am providing this big three. Okay, and you are gonna do this same thing when you write a C++ program all the time. If the big tree is needed, then provide it. If it is not needed, write it in the code. And during the exam, you are going to do the same thing too. And I will be very careful about your big tree. If you are not writing your big tree, okay, that means that it is not needed. But in fact, if it is needed, then you are going to lose serious amount of points. Okay, good. So let's look at the implementation of these one by one. But I don't think that I am going to have that much time for the implementation, but maybe I will complete this tomorrow. But before doing that, let me go back to this. Okay. Usually people would ask this. This is my copy constructor. And number 3, the copy constructor is called whenever I make a call by value, right? So the people usually ask this: what happens if I erase this? I write a constructor. Okay, it takes a constant money object, not by reference but call by value. Okay, and after that I am calling this function m1. There is a very bad problem happening here. This is a copy constructor because it takes a money object. It is not a reference, but it takes a money object. So the copy constructor takes a money object by call by value. Who is going to make the copy of this m1? Copy constructor, right? But the copy constructor takes the parameter by call by value. Who is going to make that copy? Copy constructor again. But I am in the copy constructor, so copy constructor is calling the copy constructor over and over and over and again, and we call this what? We call this problem what? We call this problem infinite recursion. Infinite recursion. if you don't put that ampersand in there, okay, your copy constructor will be called every time you need to make a copy, but copy constructor has to call the copy constructor again to make a copy, and that will be an infinite recursion. That's a bad thing. That's why copy constructor has to take, okay, copy constructor has to take its object by reference, okay. Question. Another question. If I take this copy constructor from this position and paste it here, what happens? I made it private. So if I do that, it turns out that our customers will not be able to use our class objects for call by value. They cannot write like this kind of code. When they write this kind of code, the compiler will say that you cannot make call by value function calls with the objects of this class because copy constructor is private. Okay, so your objects of this money class cannot be used with call by value outside of the class. Okay, also this will not work and this will not work, and you cannot return these kind of value objects of your class if you do that. Okay, sometimes you may prefer doing it that way. Okay, so this is a very rare situation, but okay, I am not telling you these just because sometimes you may need it. I am telling you this so that you can understand what the copy constructor is. Okay, good. I think that's it for today. Tomorrow we will continue by looking at this code, partially filled array. But before coming to class, this code is available for you, right? Before coming to class, please read this code yourself. Try to understand it. It is easy to understand. And we will make a discussion and try to compile it. Okay, where is this code actually? Is this code? I think it is source code chapter 10, 12. Chapter 10 and 12. Control C. Maybe I can put it in there, right? Just, yeah, I think I pasted it. Did I do it right? Okay. Yeah. Did you get the CPP file?
We couldn't see it in the chat.
Oh, maybe I should just hit the enter button. Okay. CPP file. Okay. Did you get it now?
Yes. Yes.
Okay. So compile it, run it, try to understand it, modify it. One exercise for you for tomorrow. This partial fill array says that I am full, I cannot add more. Modify it so that it is not full, okay? Whenever it reaches its capacity, increase its capacity and continue, okay? Increase its capacity and continue. So modify the class so that it is never full. It's like the vector class of the STL library. So it is always, you just push back, and it works, okay? Good. Okay, see you tomorrow morning then.